Hi, I'm Jude. Welcome to my Java programming course. In this lesson, we are going to learn everything about abstract classes and interfaces in Java. This video is part of a complete Java course I have published on YouTube. If you are interested in becoming a Java expert, I would highly encourage you to check out the rest of the videos as well. Generalizing logic is basically art in programming. This lesson is very important because let's imagine you've been asked to develop a software application. The software solution you will come up is similar to something like this one because it lacks the shapes, colors, and more advanced features that you could have implemented. But an experienced developer will include those factors whenever he or she develops the program. So the knowledge you will gain out of this particular lesson will allows you to draw something like this output. I want to make sure everyone who watching this video knows these English terms: object type, reference, and object or instance. Object or instance, it's the same thing. We refer the object that we create out of a class. It is more like pointing a remote to an object. Inheritance is a special term in programming. It is not bound to Java. Let's imagine we have a parent-child class mapping. In this case, the school principal acts as the parent class and the child class is the teacher class. Inside the teacher class or the subclass also have the same method but a different method implementation. A setup like this demonstrates a parent-child relationship, and the behaviors or the methods defined in the parent has been overridden inside the child class. So make sure whenever you have a parent-child relationship, you are allowed to override methods that are defined in the parent class. That can happen inside the child class where you can define the same method signature, but the method body can be different. We say we are overriding methods of a parent or super parent classes. You know, whenever we are defining the teacher class, we must also use the extends keyword to denote the parent-child relationship. We call this entire thing as inheritance in Java. Method overload and method override, when we write on paper, they look alike the same, but they are completely two different things. It's like apples and oranges. Method overload, it's the idea where you use the same method name inside the same class. That's simple as that. But method override involves the inheritance or the parent-child setup. And also inside the child class, we are redefining or we are customizing or we are overriding a method implementation. So method overriding always involves a parent-child setup. But method overload, it's simply inside a single class, we have multiple methods by the same name but with a different signature. Let's first understand the English word abstract. Let's imagine you have a friend who comes to you and asks, it can move, it has colors, it can make sound, and people can move inside it. What is it? You are a bit confused because the explanation he gave was abstract. That means it can be any of these things you can think about. There are multiple objects that satisfy that his requirement. We can also say your friend gave you abstract information, which means no specific information, not precise, not descriptive, not clear, or not concrete. I hope now you understand the English word abstract means. Well, in Java language, we have the English word as a keyword in Java. The abstract keyword is a reserved keyword in Java, and we can mark or decorate classes and methods in abstract way. For example, let's imagine you have a class called vehicle and you mark or decorate with the abstract keyword. It has to be written before the class keyword. So abstract class and the name you want to give to the class. In this case, we provided the vehicle. As soon as you mark the vehicle class as abstract, you are not allowed to create objects. For example, you cannot write a statement as follows. That is forbidden because vehicle class is an abstract class now. Abstract means no clear, not precise, and no concrete implementations are available in this class. Therefore, Java does not allow you to create objects out of an abstract class. Like I said, you can also mark methods as abstract, but make sure you must be inside an abstract class to do so. For example, in this case, we have the vehicle class, and inside the vehicle class, I have marked a method called getSeatCount as abstract. Once I mark the method as abstract, I must not provide an implementation because I do not know that knowledge. That's why I decided to mark that method as abstract. But of course, you are free to define any other implementations you require inside that abstract class. You might be wondering what is the purpose and when to use abstract classes. Basically, whenever you have an abstract class, that means you do not know the complete knowledge about creating that object. You delegate that responsibility to all your subclasses or child classes. That's where you must use an abstract class. You are allowed to create objects out of these child classes, but you know it is not allowed to create an object from the abstract class because abstract class do not have the complete knowledge. Let's revise our understanding of inheritance. In this case, we have the Toyota Corolla car and I created a class to represent or create an object of Toyota Corolla car. And later, we have also Toyota Corolla Special Edition. Now, this is clearly a basic inheritance example where we can extend the regular Toyota Corolla class into an special edition Toyota Corolla class. What I can do in this case, I can provide additional implementations inside the child class or the Toyota Corolla Special Edition. At the same time, I also have the ability to override the existing behaviors that are defined inside the parent class. In this case, I have shown you I overridden the start method by providing my own implementation where I try to provide the facility to start the engine by pushing a button. With this simple example, I hope you understand inheritance and how you can override methods from the child classes. Now let's imagine a situation where you might consider using an abstract class. In this setup, we have the transportation as an abstract class. Inside this abstract class, I marked a method called move as abstract. So the intention I have, any class that extending from the transportation abstract class must provide their own implementation of move method. So in this case, we have two child classes, car and airplane. They provided their own implementation of move method. When you are coding this example, you are allowed to create car objects and airplane objects. However, you cannot create transportation objects because we mark that class as abstract, and in fact that means it lacks of implementation details. So you cannot create an object out of an abstract class. What if all the methods in an abstract class marked as abstract methods? And that's where the interfaces comes into play. It is completely fine. You imagine when I say the word interface, you thought something like this. But that is not what we are talking in this lesson. That is actually called as user interface. We are not talking about user interfaces. In Java, we have something called Java interfaces. Java interfaces are special constructs just like classes. But this is completely different. Interface is a reserved keyword in Java. We can create interfaces in separate files just like we create class files. So when we create an interface, we use the keyword interface and the interface name we want to provide. Just like an abstract class, you are not allowed to create objects out of an interface. You remember the main idea behind an interface is basically all the methods are by default marked as abstract. Whenever you create an interface, you are not allowed to provide method implementations. You are only allowed to write method signatures. By default, that means all the methods become automatically abstract. Here is the catch. A class can extend only a single parent, but a class can implement multiple number of interfaces. Did you get that right? Let's imagine you create an interface called connectable. It is an interface. This is not a class. And it can only provide method signatures. In this case, I have two method definitions or signatures called connect and disconnect. Now we have different classes. We want to implement this particular connectable ability in these two classes. As soon as you mark a class that going to be implements an interface, that means that class must provide implementations for all the methods defined inside that interface. In this case, you can see the connect and disconnect methods must be implemented inside the child class. Let's create a new project in IntelliJ IDEA. Let me call it example art. and press enter. So here we have the automatically generated main class and we don't have anything else under the src folder. I'm going to clean up whatever has been already generated for me. Well, you can run this program and make sure everything works as expected. Of course, you will not see anything. Our first goal is to represent the following inheritance example. We have two entities, landline phone and smartphone. We can map them into two different classes. And we have a relationship among these two classes. We can use the extends keyword to denote the parent-child relationship in Java. If we look further into these two classes, the first one, the parent class, we have a method called makeCall. And inside the child class, we have a different method called sendSMS. You know, a smartphone can send SMS. But on the other hand, land phone does not allow you to send SMSs. So this is an additional functionality or the feature that has been provided only to the smartphone or the child class. Let's go ahead and implement this following scenario. Inside our src folder, I'm going to right click and create a new package called org.communication. Inside this new package, I'm going to create a new class called landline phone. Inside the landline phone, we have only a single method, that is makeCall. Let me go ahead and create a new class called smartphone. Now, according to our situation, smartphone is extending from the landline. Therefore, I need to make the adjustments at the class definition level. I use the extends keyword and followed by the class that I want to extend from. In this case, that will be the landline phone class. Inside the smartphone class, we are not going to override any methods that has been inherited from the parent or superparent classes. Instead, we are going to write our own method called sendSMS. Now let's switch back to our main method. Let's create an object from the landline phone class. From the last lesson, we learned about access modifiers. If you look into the left side, we created the landline phone and the smartphone under the org.communication package. But our main method is written inside the main.java file. But that is outside the package that we define the classes. Therefore, we are not allowed to call these methods because we did not use any access modifiers inside the two different classes we created. Let's mark the methods as public and then we are allowed to call those methods wherever we create the objects out of those classes. Now let's switch back to our main method. You can see the error has disappeared. Similarly, what I'm going to do is I'm going to create a smartphone object. You can see I am allowed to call the makeCall method as well as the unique method that we only define inside the smartphone class, which is sending an SMS. Let's run the program and observe the output. You can see the first output is coming from the landline phone object and second two outputs are actually coming from the smartphone object. Since the smartphone class has been extended from the landline phone, we can also write something like this. Since the phone reference is the type of landline phone, you are allowed to call methods and variables that are defined into the parent class only. In this case, you cannot see the variables and methods defined in the child class object. For example, in this case, even though you have a smartphone, you are only allowed to call the makeCall method. I hope you get that right. Because inside the landline phone, we have only this particular behavior. And since the variable or the reference is type of this class, the reference matters the most. A statement like this can question your knowledge around references. You can see the reference type is actually the landline phone. Therefore, using this reference, you are allowed to call methods or variables that are defined or available inside the landline phone class. Even though we have a specific child class which has extended features, from the reference, those things are not visible because the reference only able to see whatever things that are available for the reference data type. In this case, we are only allowed to call the make call method. If we try to call a subclass method that is not visible through the reference, you will get an compilation error. You cannot access a method defined in the child class because the reference type do not see that. The reference type is from the parent class. So make sure you get that knowledge correct. Now we are going to enhance our example further into a different situation. Let's imagine now we have a smart device concept where it is an abstract concept. Any device wants to become a smart device, they need to allow the internet connection in that device. So for example, the smartphone has to decide whether it has to stay with the landline phone or goes with the smart device abstract class. This is a limitation in Java programming language where you cannot have multiple classes as the parent. In this case, we are only allowed to have a single parent class. Whenever we are using the extends keyword, make sure you have a single parent class. We decided to have smart device as the new parent class. So we are no longer having a relationship with the landline phone class. You can see this is an abstract class and there is an abstract method called connect to internet. That means any subclass or child class from the smart device abstract class must provide the implementation for the connect to internet method. So you can see now the smartphone class must implement this particular method, otherwise it will not compile. I'm going to right click and create a new class. According to our design, we are going to make this class as abstract class. Since we made this class as abstract, we cannot create any objects out of this class anymore. And now we are inside an abstract class, therefore we are free to define or decorate methods as abstract. Let's mark the connect to internet method as an abstract method. Because we mark this method as abstract, we must not provide a method body. Let's switch back to our smartphone class. Here I'm going to change my parent class to the smart device abstract class. Since our new parent is an abstract class, IntelliJ IDEA already identifies that we still did not implement the abstract method in our child class. Therefore, it shows you an error at the class definition level. If you press Alt and Enter keys together in IntelliJ IDEA, it will show the recommended fix. In this case, we must implement the connect to internet method. Let's press Enter, so it will automatically generate the implementation inside the smartphone class. So you will get this particular pop-up and then press Enter. You can see the IDE has already generated the correct signature that is complying with the abstract method inside the abstract class of smart device. Let's write a basic implementation. Now let's switch back to our main method. Our previous inheritance setup is no longer valid. There is no relationship among landline phone and the smartphone class anymore. Therefore, you can see line number 13 will no longer work. I will remove these two lines. You can also see the smartphone object no longer have a make call method because we no longer have the previous inheritance relationship. Therefore, we have to remove this method as well. Thanks to our new inheritance mapping inside the smartphone, we are allowed to connect to the internet. But you can see there is a compilation error. If you hover over the error, you will see the IntelliJ IDEA shows the root cause for the error. This is related to the last lesson we learned. The root cause related to the access modifiers. IDE already suggesting to make that method public. Let's click on that option. Now you can see this method compiles fine, and let's go ahead and run the program and see the output. This line is actually coming from our landline phone object where we are trying to make a call through the landline phone. And then we have the smartphone where we are sending an SMS and then connecting to the internet. Going beyond the smart device abstract class, now we are going to use an interface. Let's call this interface as voice control, and it has a single method called activate voice control. Note that we no longer need to use abstract keyword, but also there are no method implementations when we write an interface. And also make note that whenever we are using or implementing an interface, we use the keyword called implements. And whenever we are having a relationship among classes using the inheritance, we use the extends keyword. Now, our smartphone class has to provide implementations for the methods that are defined inside the interface. In this case, we have the activate voice control method. Let's go ahead and code this scenario. I'm going to create our new interface called voice control. Right click on the package, go to new and go to Java class. Let's provide the interface name here. And make sure with the arrow keys, select the interface, not the class. You can see this is an interface. This is no longer class. I'm going to write the method signature called activate voice control. You don't need to write abstract keyword in the method signature. Now I'm going to switch back to my smartphone class and going to implement that particular interface. I'm going to use the implements keyword and then provide the interfaces I need to implement. In this scenario, I have a single interface called voice control. However, you are allowed to have multiple interfaces separated with the comma sign. Just like the case of abstract class, even when we are implementing interfaces, IDE already identifies the methods that we must implement in our class file. In this case, we can press Ctrl and Enter and use the implements method option. Then press Enter. You can see it generates the correct method structure for us. We only have to provide the implementation or the method body. Let's switch back to our main method. I'm going to call the new method through my smartphone object. Now, just like inheritance, you are allowed to create child object and assign it to parent types. We are also allowed to create child objects and assign them into reference types of interfaces. Let me show it with an example. If you have noticed during this exercise, we did not have any problems related to access modifiers for the activate voice control method. That is because we define that method inside an interface. Any method that you define inside an interface will automatically considered as a public method. You cannot use protected, private, or even default access modifier inside an interface method definition. For example, if we switch back to voice control interface, so here you can see inside the voice control interface, we did not mention any access modifiers for the method of activate voice control. So you might question me, Jude, you taught us that if you do not provide an access modifier, that will be considered as default access modifier. Yes, that's correct. But we are talking about an interface here. Inside an interface, any method or even a variable, you can only use the public access modifier. You cannot write protected, private, or so on. This will not compile. This will give you an error. But of course, you are allowed to write something like public because that's the only keyword that is allowed. But as you can see from the IntelliJ IDEA, the IDE itself already identifies it and says this is a redundant work. You should not write it because everybody knows any method that you define inside an interface, that's going to be public method. So you might have the question when to use an abstract class, when to use an interface. So here I have represented the class. It's the complete concrete implementation. That's where you can create objects out of classes. Abstract classes do not have complete knowledge, but you are free to define method implementations inside the abstract classes. That's why they are saying abstract, which means they have only a partial knowledge. On the other hand, interfaces do not have any knowledge. They only have method signatures. The implementations must be available inside all the classes that it implements. So now you have complete idea about classes, abstract classes, and interfaces, and they are having different levels of knowledge about the underneath object. Since abstract classes and interfaces do not have complete knowledge about the underneath object, Java does not allow you to create objects out of these constructs. Alright, my dear students, since we came to the end of this video, I want to summarize what we have learned together. We started off reviewing few English words such as reference, object, and instance when it comes to Java language. Later, we also discussed what is the meaning of English word abstract means. After that, we understood the difference between the method overloading and method overriding in Java. We also now understand what are abstract classes and how to define abstract methods which are only available inside the abstract classes. Later, we also identified there is a new construct called interface and the importance of using an interface compared to an abstract class. With this knowledge, I invite you to join with me where we are going to learn about static and final keywords in Java.